So in this session, we're going to start from scratch again. We're going to close your Jupyter notebooks that we've just made, come out of your environment that we've made. We're going to make a brand new environment as it's a brand new project, and we're gonna go up from there. And as I alluded to, I think in the first session and at the end of the second session, this is going to be, for those of you that know Python quite well and have used it, this won't be too bad for you. For those of you that this is all quite new to, really is going to be a jump in the deep end. But there's method to my madness here. First, we get to show you something cool in Python. Well, I think it's cool, and some of you'll see how powerful it can be. Secondly, there's only one way to introduce new concepts, really, and that is to just throw them at you, and hopefully you'll learn a bit. And thirdly, by doing this, I will explain what some of these more complex things are as we go along. And even if you don't understand them now, you'll have a feeling for them, and it will really help you when you actually come to learn them properly. In 2 weeks' time, when we do the Python 2, still an introduction to Python really, we'll backtrack a little bit, and we'll do it a little bit more normally and explicitly, where I'll go through the different data types in Python. So what might a number be? What might a letter be? And we'll build up in a more normal sort of teaching way. But I thought, let's jump in this session. Let's do something a little bit interesting and a little bit less dry. So the first thing I need to do is share my screen. I've just realized. And give me a second. Desktop 1, share. Okay, so everybody should be able to see my terminal. So I've got a brand new terminal open. You'll see here, I'm in the base environment, the default environment, not done anything just yet. Now, what we're going to do is we're going to use a library called RDKit. And this isn't like your normal easy to install library like Jupyter. In fact, it isn't like Jupyter at all. Whereas Jupyter was a notebook that allowed us to code, RDKit is a set of functions that do interesting things in the cheminformatics space, and you'll see some of those things. So whereas Jupyter was something a tool that we could use to make pretty pictures, pretty code, bring everything together, make things usable, the RDKit is more maths. It's more, okay, we have a chemical or a molecule, mathematically, chemically, scientifically, what is going on here and what can we do to it? And because of that, it's a little bit more difficult to use, I suppose, in a sense. So the first thing we need to do, before I explain a little bit more about the RDKit, is create our environment, just in case it takes a little bit of time to run. And here you're going to see that the creating environment command is slightly different. And I'm not going to go, in this session, I'm not going to go into why it's different or what it's doing. I think all you need to know is that it is different because it is quite a specialist piece of, I suppose, software, for want of a better word. It's quite a specialist library set of libraries, set of packages. But the format in getting this is still fairly similar. So even the code might be a little bit foreign, you'll see that the overall format is quite similar. So just a thumbs up that you can see my terminal screen, just in case I'm sharing. Excellent, got the thumbs up from Nikki, fantastic. So in order to download RDKit, the best way to do that is to create the environment and download it into the environment in one fell swoop. This is how they like you to do it. So the first thing we're going to do is we're going to type Anaconda, as always. You'll see that the format's still quite similar. We're telling Anaconda that this is a command for it, nothing else. And again, we want to create an environment, so we're typing the create. This is where it gets a bit different. I'm going to say -C, Anaconda Forge. And I know this probably sounds quite mean. I'm not going to go into what this is right now because it's a little bit outside the scope of what I actually want you to learn from this. But it is slightly different to what we did before. And as I said, the reason for that is because RDKit is quite specialist. And it's coming from a slightly different place in the Anaconda ecosystem. And then -N, that just means dash name. It's another way of saying, okay, this is what we're gonna name it. And I'm gonna name it my RDKit environment. And I'm gonna name it my RDKit environment too, because there's a chance I already have a my RDKit environment. But you guys might want to just name it my RDKit environment or the RDKit environment or whatever name means something to you. It's good to get into that habit now. And then we're just going to say it's got to come from the RDKit section of Anaconda. That's where we're finding it. And if we press enter, we can see that it's collecting our packages and our metadata, and it's whirring. And you see that this is exactly the same, even though the words are slightly different, the format is exactly the same as before in that we've said Conda, so we're giving it to Conda, we're creating something, we're naming it, and we are, and then we're running it. And you see that it says collecting packages, solving environment. That's exactly what it said when we made our environments before. It's just in this case, it's slightly different because we're doing everything in one fell swoop. We're installing everything, importing everything, creating everything. And then again, if I just scrolled up, it says the following packages will be downloaded, exactly the same as before. We need, for our RDKit to work, we need all these packages here on the left. Now there's this other column that says build, and that's because we're coming from Anaconda Forge instead of just normal Anaconda. And these here, these are just, for want of a better word, they're pointers. They're directions to things that we need. And then here we have the size of these and then where it's coming from, which is the Anaconda Forge. And again, it says these new packages will be installed again. And again, where they're coming from, and then proceed, yes or no. We want yes, so we type Y, we press enter. And then this might take a little bit of time on your guys' machines, but I always think when I first started programming, I thought this was really cool. I thought, yes, I've cracked it. This is what they do in the movies, on TV. But you can see that it's downloading these packages and it's extracting them for us to be able to use. And this will go on for a little while. It depends on how good your internet connection is, among other things, how quick your computer is. And these are all the packages that it told us it was going to download, and it just gives us a percentage to say, okay, how downloaded are they? And this will just whir away until we've got everything that we need. Mine seems to be going pretty quickly today, so that's good. And for the eagle-eyed and the people that know Python among you, you'll see that there are some quite common packages that we need for our RDKit to work. So matplotlib, very, very well-known package. NumPy, I think some others, pandas in here, real bread and butter things that everyone uses. And I think this is a really, really good point that even though you have even though you might install one package, it's probably built upon a load of other packages. So don't think that you're the only person that's saying, okay, I need to use this person's work. Don't want to reinvent the wheel here. All the packages that you need, they're installing and importing packages that they need for their package to use. And in this way, you bring everything together into I suppose, an ecosystem of things. Sorry, I haven't got the chat up at the moment. So it looks like there are some questions. Let me just scroll to the top. Sorry, my Zoom has been quite annoying. Aha, here we go. Right. So we have a question from Dave. What is the difference between a library and a package? And I've used them quite interchangeably here, and that's probably my bad. But I just it's probably easier just to say them as I'm saying them when you're talking. But if you want a definition, a library is probably a single file that contains quite a number of different functions that you might need. Whereas a package, so a library, you might need a function that calculates the mean, that calculates the product, and calculates the sum. And a library might have all of those inside of it. Whereas a package might contain multiple libraries. So if you have a library that contains those things, and then a library that contains, I don't know, how to take things away, how to find square roots, how to use powers, the package would have both of those libraries in. That's probably a pretty poor example, but the words are used quite interchangeably, and it's yeah, they do mean slightly different things. If you want a much more technical definition, because there is, you need to start looking into things called executables, and the package is it's a way of distributing, or a unit of distribution that contains executables, but that's way beyond the scope of what we're doing here. But if you're interested, they're sort of the terms you need to be Googling. Yep. So Ahmed said, how can you check the available packages or kits in for Python in Anaconda? So you want to know what Anaconda contains. Excuse me. Great question. Off the top of my head, I can't remember how you delve into Anaconda to see exactly what it has. Probably not that difficult to do. There is, if you go onto the, if you go onto the Anaconda Navigator, you go into environments, you choose your environment, and then you click on that environment. If you remember, on the right-hand side of the screen, all the packages that are in that environment are there. You then, at the top of the screen, there is a drop-down menu where you can search for different packages. And in that drop-down menu, you can say, I'd either like to search for the packages that are in this environment, or I'd like to search for the packages that are within Anaconda. And that will show you all the different packages that come pre-made or pre-bound in Anaconda. So that's one way of finding it. Or if you just Google is your friend here, and it will, there'll be a list somewhere. If you're looking for a certain package in deep learning, so then if you're looking for a certain package, it's better to go to the documentation of that package. So for instance, if you want scikit-learn, which is for a lot of stuff in there for like machine learning and prediction, then go and read its documentation. In its documentation, it will tell you how to install it. Or failing that, go to its Git repository. It will tell you where the best way to get it, how to get it, and how to use it as well. And as Nikki said, there is information online on the Anaconda page of what the default ones are. So I think that's everyone's questions so far. And great. So my RDKit environment has finished installing. Installing and being created. So as before, we want to say conda activate my what have I called it? My RDKit environment 2. And excellent, I'm in. Now, if I look through on the list, we can see that because we're in our new environment, oh yes, and put some thumbs up or thumbs downs or yay or nays in the chat to check that the RDKit has worked properly and has installed properly. But if we look through here, we're in a new environment and we can see that there's no Jupyter. And this is what we, as I said before, this is what we want to do 90% odd of our work in until we get to that production ready stage where we need to scale it up, distribute it either commercially or in a big academic sense. And we don't have it. So we also need to go back again and say conda install Jupyter into this new RDKit environment. Now, that's excellent. So whilst that's installing, a little bit about RDKit. And as I said, sorry for you guys that aren't chemists or don't work with atoms, molecules, compounds in the things that you do, but I use this fairly regularly. And RDKit, it's open source, and its primary focus is for carrying out cheminformatics calculations. And so that's doing calculations on data and information to do with chemicals at the end of the day. And it also has some machine learning capabilities in there, but you probably want to use other packages for that. And the thing with RDKit is that it's not written in Python. It's written in another language called C++, which for a number of reasons is, again, it comes back to the question that was asked before, MATLAB or Python. For a number of reasons, C++ is better than Python. It's what's called a compiled language, so it's much, much faster. So if you need to do big calculations or you need to do very complex tasks, C++ is probably better. Though Python can be fast if you use lots of tips and tricks. And one of them is, yes, RDKit might be written in written in C++ under the hood, but it's able to be used in Python, and you are able to use it by calling Python and Pythonic commands. So they've made it in such a way that they get the benefits of C++, which is very fast, but they also get the benefits of Python, which is very easy to write, because C++ is a bit of a more difficult language to code in than Python is. So it contains a number of functions that allow someone to load in and interrogate different chemical structures, like I've said, and calculate different properties or different molecular properties in there. And it's got a huge functionality. There's a getting started page because we are barely going to scratch the surface in what we do here today. And there is also a mailing list. So if you decide that you want to start using RDKit a little bit more, I highly recommend signing up to the mailing list. And Greg Landrum, the guy that invented it or developed it, he's the most cleverest person in the entire universe, and he's just a great guy to talk to. So if you have any problems with the RDKit, send a message into the mailing list, and you'll literally get the guy that invented it email you back trying to solve your problem. He's a fantastic chap. So we've installed RDKit, and it looks like there's something wrong with my install of Jupyter, which is never a good thing. So I'm not quite sure what's going on there. Has everyone else managed to install Jupyter into their RDKit environments? Yep. Still going for Nikki. Some people have said yes. Some people are getting the same conflicts. Some people it's installed pretty quickly. Interesting. One of the problems with doing a live code along. I did this yesterday and it all worked perfectly. So it looks like some people are getting the same problem I'm getting. Some people it's gone all the way through. So what it's doing at the moment, it's examining each of our packages that have come with RDKit, and it's saying, where is the conflict? So it may well be that RDKit, it needs a certain version of a package. And the package we have in our systems is a slightly older or slightly newer version. And there it finds a conflict and it can't work. Now, if this doesn't work, what I will do is I will load up another one of my virtual environments that has RDKit and Jupyter in it that I know works, that I use regularly, and I'll continue on. But that doesn't really help those of you that are having these issues. But what we can do is we can go through. Nikki is saying that it might have done Python 3.9. That will be an issue. One of the things I like to do is always stay a little bit behind the latest Python releases. So if we're working in Python 3.9 here, I always quite like to work in Python 3.8 or 3.7, just because you don't run into compatibility issues like some of us are finding here. So William's got 3.9.6. Has it worked for you? Aha, so it has worked. Okay. Well, this is taking a little while, so let's crash out of this. Different environments. So it's Python 3.8 that ended up with conflict. So maybe then we do need to use Python 3.9. Interesting. Okay, well, this is all good to know. So it may well be then that we need to have this in Python 3.9 for it to work, but that's no issue. So it may be good. It might be good then if you, as Gavin's just said, if you upgrade your Python basically to Python 3.9 in your environment, and that may get past this issue. But let me just open a new notebook. The problem with making a new environment is that the way to install RDKit is it likes to make its own environment. So if you can upgrade your Python in there, then that will hopefully work. If not, I'm just sorting out. 1 second. I'm just sorting out my another environment for me to be able to continue on and show you guys. Excellent. So if I share this screen. From Python website. To get Gavin, to get the latest version of Python, yes, that's one way of doing it. Probably given our time frame and where we are at the moment, that's probably the best way for you to go about doing it. There's also, if you Google update Python update from the command line, it will give you a command to do that. Right, can everybody see my Jupyter notebook now? Excellent. So apologies for these problems. As I say, I tried it all yesterday and it all worked perfectly. So there may well have been an update done to RDKit or something recently that's thrown it all out of kilter. But as I say, all of this is recorded. So for you guys that have got left behind, sorry, but you'll be able to rewatch it in the recording if you so wish to go through the stuff. So the majority of the functionality that you will need to use in the RDKit for reading interrogating molecules is in the chemistry package, and that's here from RDKit import chem. So what we're saying here is we're saying, obviously, this is one of the great things with Python. What you see is what you get. So from the overall RDKit that contains absolutely everything to do everything with chemicals, we just want to import one bit of that functionality. And this is the chemistry package. And this is what's called namespaces. So here we have invoked a namespace, which just means that it's this section of this overall functionality that does this thing that we want to use. And basically, the reason you do that is because with something as large and as varied as the RDKit, it makes absolute sense to break it up into small units that can be used as and when that are needed. And obviously, as we in allusion to one of the questions we had before, packages allow that to happen. They provide this almost hierarchical structuring of the module, of the namespace, and we can then use that. So what we want to do early doors is something that I think is quite cool, and we want to just visualize a molecule. And to do that, we have to very quickly go over how to input the structure of something, of a molecule, into the computer, into a language it will understand. And that's using something called a SMILES string. And SMILES stands for Simplified Molecular Input Line something notation. So it's basically, you simplify the letters of a molecule into some sort of notation and put it into your computer. So how do we do that? Well, for those of you that aren't chemists, you probably won't know what a benzene ring is, but a benzene ring is just a series of carbon atoms that go around in a circle. They connect at both sides. And so for us to do that, what we want to do is we want to define molecule 1 as our variable name, and we want to say this equals. Now, this is where it gets a bit complicated. We say chem, because we want to use this chemistry package, this chemistry library, sorry, which has a whole host of functionality for doing chemistry. And we want to say mole from SMILES. And then we want to put, and our SMILES string is our way of inputting a chemical structure in, C1, 1, 2, 3, 4, C1. Now this has probably gone from 0 to 100 pretty quick. But what's happening here is we are defining a variable name and defining it as molecule 1. So now, whenever we call molecule 1, or whenever we want to use molecule 1, the computer, it knows that it's this thing here, this chem.mol from SMILES. And what this is saying is that we're inside the chemistry package, and we now want the function, because inside the chemistry package there is multiple different things that it can do. We want the thing that returns a molecule from a smiles string. And this here is our smiles string. So if we now press Shift Enter to run this, we have nothing, no output. But we know that it's run because we've said we have input number 2. And okay, that doesn't really seem that exciting. But what's gone on here is that we've now, into our memory, it now knows that there's this thing called molecule 1 that is this benzene ring. So if I type print molecule 1, and print is an inbuilt function in Python. And what its whole purpose is when you say print, it prints to screen the thing that you are asking it to print. So it's a way of putting on screen and visualizing the thing that you are doing. So if I say print molecule 1, what we get is something that's a bit horrible, but it's saying this is the function that we're using and this is where it is in memory. Okay, great. Well, who cares? What does that mean? Because we're in Jupyter, what we can do is we can just type molecule 1 and we can run that. And all of a sudden it's visualized our benzene ring. And so this is what the C1 looks like when a chemist draws it. And so I'm sure you can start to see how powerful this is, because in 2 lines of code, we've managed to draw a chemically accurate and structurally useful molecule, and we've managed to input that into the computer for us to then go and do some work on. And we can, I suppose we can make some more. So if we say molecule, I can't spell today, molecule 2, and again, we want chem.mol from smiles, and we can make a different molecule. So for instance, let's just say propane, 1, 2, 3, and we press Shift Enter. Nothing's happened because we need to call molecule 2 from memory. And here we have propane. And these might just look, for the uninitiated that are chemists, these might just look like lines, but this is how chemists draw different molecules. And what's great about this is now that we've instantiated these variables, and now that they are saved at this place in memory, I can now use molecule 1 or molecule 2 wherever I might need to use it. So okay, we've used it, we've called it up here and we've had a little look and it looks quite cool. Well, I might want to see it again down here in order to then go on and do something further onto it, which we will do in a second. So if I run this cell here, we can see that we haven't had to write all of this gubbins saying chem.mol from smiles, blah, blah, blah. We just have to call the variable. And this then allows us to use it wherever we need to in the script. So that's great, fairly interesting. I think that's fairly cool. We've in no time at all we've managed to print a cool atom or molecule to the screen. And smiles can get really complex. So there's one, if I just can find it quickly, here, which you guys won't be able to type out because I can just copy and paste it. But let's change molecule 2 here to having this smile string. If I run that, we can see that molecule 2 hasn't updated yet because all we've done is we've saved an instantiation in memory of this new thing. But now, because we've updated the name, variable name molecule 2, we can run it and we have a much larger molecule, something a bit more interesting to do some more interesting chemistry on. And then the final thing to talk about here, because obviously we are using this to, could you copy the smile string into the chat? Of course. So here we go. Here's this one. And the final thing to mention here, because obviously we're using this to introduce some concepts in Python. Inside the brackets in the chem mole from smiles, we're inputting our smile string. This is our input. But as you can see, we've had to put parentheses around it. And that's because this is what's called a string. And a string is special in Python because it is a bunch of letters and numbers, but when you put the parentheses around it, that is what it is. It's a bit more complicated than that, but for right now, it's good to know that that is just then what it is. If we were to remove these parentheses from around it and we press go, we'll see that we have an invalid syntax. And that's because now this chem mole from smiles function, it's trying to enact whatever its functionality is on this thing that it doesn't recognize, because we've not told Python that this is a string and it only works on strings. And so it will throw up an error message. This is another fantastic thing about Python, and a great thing about Jupyter Notebooks, is that we have this error message and it's saying this thing here, we have a problem on line 1, which is the fact that it tells you what line the problem is on is really, really cool. If anyone here has experience in coding in Fortran, that was made years and years and years ago, that doesn't tell you where the error is. And in fact, it doesn't even tell you that there's an error. It just runs and runs and runs and doesn't do anything or produces nonsense. And then it's saying here, the offending line. And it tries to give a best guess at where in the line the problem is with this little arrow. That can be a bit misleading at times, but most of the time it's quite useful and helpful. And then it tells us the what what type of error it is. And there are lots of different types of error. This one is a syntax error, where it says invalid syntax. And that means all we've done is we've missed out our parentheses like this. So there is a module not found error. No module named RDKit. Now, it may well be, says A, apologies if I've mispronounced your name there. Are you running this Jupyter Notebook in your environment that has RDKit? Because if you're not, then it won't be able to find the RDKit module because it's not in the environment that you've made. So that should be your first port of call when trying to troubleshoot that problem. If that doesn't work, then yeah, come back to me. I'm not really sure why you would be getting that. But if everyone can see the chat here, you can see that Sezai has had a different type of error. He's had a module not found error, which was different to this syntax error that we had over here. And that's Python. Obviously, it's another type of error. It's Python doing its best to troubleshoot your problems for you. No module named RDKit. Great. It's quite obvious what the problem is. The fix is not so easy. And Louis said, on updating Python, do I need to recreate the RDKit environment? Yes, you do. If you don't recreate the RDKit environment, I see. Yeah, I would update it just to stave off any issues that you may face. Depending on a few things, it may well automatically do it for you. But one of the problems with Conda and Python and all these sorts of things is what's called a path issue. So where it looks for the various modules and packages that you need in the computer, that might not update automatically. It's not a given. So I would, if I were you, Louis, recreate the RDKit environment. So great. We've made these molecules. We've printed them to screen, and now we want to do something a little bit more interesting. So what should we do? Yeah. So what we can do is we can loop over our atoms and bonds. Could be quite useful to tell us what atoms are there and what the connectivity is and what's going on. So let's stick with molecule 1 for the time being, because it's nice and simple, it's nice and small. And what we're going to do is we're going to write what's called a for loop. And again, this is a concept in not just Python, but in programming, that is very, very powerful. And you don't just have to use this with RDKit to loop over atoms, as I'll explain. Excuse me. It's a concept that will allow you to very quickly go through an awful lot of different inputs and run some process on them. So the way we write a for loop is we say for, and in our case, we want to loop over our atoms. So we'll call it atom, but I'll come back to this in a second. You don't have to. In molecule 1 dot get atoms. If I just quickly write the next part, like this. Right, let's unpack this a little bit. So in this example here, we have what we're asking the machine to do is we're saying for each atom in the atoms in molecule 1, we want to print the number, the atomic number of that atom. Okay, and the atomic number is just for all intents and purposes a weight of that individual atom. So if we run this and see the output, we'll see that because these are all exactly the same atom, they all have the same atomic number. But let's go a bit deeper than that. What is it that this for loop's actually doing? Why have I said atom here, atom here? What's going on here? Excuse me. Well, in this example, we have something what's called an iterable. And the iterable is the thing that you are iterating over. So this molecule here has 6 atoms in it, and we want to look at each of those atoms individually. But we don't want to tell the machine 6 times to look at, right, now I want to look at atom 1, now I want to look at atom 2, now I want to look at atom 3. We want the machine to just say, okay, it comes as 6 atoms, now I need to look at each one of those in turn. And you want to iterate over it. So that is our iterable. We are going and we are looking at everything in it. We are then saying, right, the thing we want to look at is molecule 1, and we want to call from the RDKit chemistry library the getAtoms function. And this function is just something that takes in our molecule 1 and specific way. Yeah, so sorry, Dave, I missed your question there. Is molecule 1 a variable or an object? Your output said rdkit.chem.mol is an object, but I don't know if that's something different. So yes, absolutely. So molecule 1 is an object. Everything is an object in Python memory. But the name molecule 1 is the variable name we have assigned to that object. So that's how we then go and find that and use it. And I think Kevin has, yeah, he's answered that brilliantly. That's exactly what it is. So back to the for loop, we're using this function on molecule 1, and then what we want to do is we want to print to screen atom, our iterator, dot get atomic number, which is the, as we've said, the weight of the atom. And this for loop is, a for loop is always written in this fashion. So just like when we were using the conda commands, and they all followed the same principle in, for instance, conda creates something, something. A for loop always has for something in the thing you want to look at, do something, go over it. So a great way of looking at this is if I quickly make a number list. We in our number list, we say 1, 2, 7, 8, 10. And we want to just, we can quite easily see what's in that number list right now. But if we wanted to print to screen each number in this number list, we would say for I for our iterator, because we can call that whatever we'd like. In our number list, print I. So again, we can see that even though this is quite different, the format is exactly the same. And even though we've used different names and different, and we've not called functions, the for loop principles are exactly the same. For a number in our list, we just want to print that number. And that's exactly what's going on here. For an atom, we want to print what's going on with that atom. So that's a quick introduction to for loops and what they can do. And we printed to screen there some of the things that are going on. It might be quite cool to do this for molecule 2, because obviously it's a lot bigger and there's a lot more things going on. But what we'll get is we'll just get a bigger list of numbers, and they might not mean as much, but let's try it. For atom in molecule 2, atoms, print this. And here you can see in my print function, I've put one too many closed brackets at the end, and it's come up with red. And that's Jupyter telling us we've got too many brackets, you need to get rid of one. And here we can see that actually the atomic numbers vary because the atoms vary in this new molecule. But it's not really, there's quite a lot of atoms in there, and it ranges over quite a few different ones, but it doesn't really tell us too much information, because it's unlike here, it's a lot, unlike with the benzene ring, it's very difficult to relate this back to the atom, to the molecule that we're looking at. So we might then want to do a bit of substructure searching. So in molecule 2, if I just print it back to screen, we have quite a lot of different things going on. I'm curious from where it starts to count atoms in a big molecule, in which order. It goes in smile string from the beginning to the end. That's a really good question. And in a simple molecule, it will start. So for instance, in the propane that we made, I think I've got it off my screen. Yes, it will start from the very beginning of your smile string to the very end. In molecule 2 here, again, the concept is the same. When you put in this smile string, it will start here, and it will go around the atoms. But what it won't do is say this one is number 1, this one is number 2, da 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 da. That's because that wouldn't work with branching. And so there is a way of printing out which atom it's looking at the time to the screen. But that's a little bit beyond what we have time for now, because we only have 10 more minutes. But it will follow basically a logical path through when it's counting them and when it's returning the numbers. In this case, that logical path could be to start here and move round here, and then come back to here and move round. But there's a pretty woolly answer because I'm not quite 100% certain how it's doing it in this case. But if you again, bit of a cop out, but Google is your friend, and it's on there. I just can't from the top of my head remember. But when it does count the atoms, it will do it logically, because if you are counting them in a way that doesn't have parity with the way everything else would deal with each of the individual atoms, you're then going to run into problems. But yeah, that's if you'd like, I can get back to you on that, or as I say, Google will definitely help you. So the last thing I'd like to do is, the second to last thing is look in the substructure search. So here we have quite a lot of these benzene rings, and we have some other things going on. So we might want to look at some of the substructures that are there. And in fact, let's use a bit of a smaller molecule that I've literally just seen. So if we do molecule 3, it equals this. And I'll paste the smile string into the chat for everybody. Oh, and as Nikki says, the documentation for RDKit is on that link. And you'll see that RDKit's functionality is humongous. So use the documentation liberally. You will always need it. So we've made molecule 3. And again, chem.mol from smiles, fantastic. As we've said in the questions before, this is a mole object. Everything in Python is an object in memory. That's what it uses. Our molecule 3 here is just what we have named it, so that we can continue to use it as and when we need. And as Nikki said, substructure searching will allow you to look inside the structure of a larger molecule. And this is fantastic, because if you are developing new drugs, it might be that it's a part of the drug that has the efficacy and the usefulness inside the body. And when you want to develop a new drug, you might say, okay, well, we know this certain small substructure is very, very useful for binding to something within the body. Now let's go and search through chemical space to see if any other larger molecules or smaller molecules have this specialized substructure. And you would want to do this computationally. The size of chemical space has been estimated at about 10 to the 90 different molecules. And that's more than there are atoms in the universe, obviously. So this substructure searching is a very powerful tool used in using drug discovery. And what we might want to do is just print molecule 3 to screen. Kind of different. And then see if we can find out if our substructure is in there. So we would want to say molecule 3 dot get atom with index 0, and I'll come into what that means, is in ring. Okay, and we'll run that, and it says false. Okay, so again, there's a lot to unpack in this. First thing you should see is that the principle is the same. We want to run a function called getAtom with index, and we want to use that functionality on our molecule 3. And that principle is exactly the same as to what we have looked at and done up here. So that's exactly the same. And here we have an index number 0. And this is an interesting quirk of Python. When we index, the 0th index is actually the first thing. So if you have 10 things in a list, so A, B, C, D, E, F, G, A is actually not the first, It's the 0th according to Python. So when we're looking here, we're looking at get atom with index 0. So we want to look at the very first one, and we want to say, is it in a ring? And it says false. No, it isn't. So Sebastian said, wouldn't you rather use the smarts pattern for substructure matching? Absolutely. Looks like it starts with 0. Yes, smarts patterns for substructure matching. Yep, absolutely. They are they're much better than smiles for a lot of reasons. Just for this, I didn't really want to have to introduce two different or slightly different things. I thought I'd just stick with the smiles. And Dave said, why does the smile string I posted into the chat start with the letter O, but in my Jupyter notebook, it looks like it starts with a 0? Well, I've no idea, but it is an O for an oxygen. So it's an O for oxygen, C for carbon. So we can say that our first atom isn't in our ring. So if we look at our second atom, and I'll just copy and paste this. It is in a ring. So we've come from here and we've come from here, and it's saying, okay, this carbon, yeah, it's in a ring. Fantastic. So we've looked for some type of structure, very simply, some kind of substructure. We want to know, okay, is this in the ring? First one, no, it isn't. Second one, yes, it is. But the key thing to take away here is the indexing. So even though this is the first atom, and the hydrogen, that's a slightly different case in RDKit. It doesn't explicitly deal with hydrogens unless you ask it to. So actually, even though it's printed the hydrogen to screen, this is one of RDKit's funninesses. It's not actually looking at that hydrogen. So our oxygen is our first atom, and then our carbon here is our second atom. And the indexing reflects that, but it's one number behind. And then just to show that RDKit is quite funny with hydrogens, if we say molecule 3 dot get atoms, we can see that it's actually saying there's only 6 atoms here. 1, 2, 3, 4, 5, and 6. But if we ask it to add hydrogens, so what we want to call this is molecule 3H, and we say add hydrogens of 3. What have I? Oh, sorry. Yep. Equals add hydrogens. Pretty sure it does. Right. There we go. We can now see that it's printed to screen, and it's explicitly said that all these hydrogens are here. And if we ask it for how many atoms were there, then it is updated to say that actually there's 14 atoms. So that is the jump in at the deep end with RDKit. And in that, we've introduced a few principles in Python. We've introduced how to import your libraries that you've installed into your environments. We've introduced this idea of namespaces and how to use different functions within those libraries. We've introduced some of the core Python libraries and what their usefulness is and what they might do as part of as your Jupyter notebook. We've spoken a little bit about Python, error messages and errors. So when something goes wrong and what it does. And we've introduced this idea of for loops and how a for loop works to save you a lot of time in what you do. And then just at the end here, we've introduced this idea of indexing and then a bit of funny business with RDKit. Now, I admit that if you're new to Python, that probably seems like such a whistle-stop tour. And it seems like we might have bounced around over a few different concepts. But when you go off and do your own projects, and especially for the interns here, if you don't have much experience in Python, this is exactly what you're going to be facing. You're going to be coming up against a brick wall of something that's completely new. And if you start to understand that the concepts are the same in every single one of your projects, just like the for loop concept or the namespaces concept here, things will start to become easier because you'll start to see patterns between problems that aren't even related. And so I think that's probably a really good place for me to stop. We'll say that in 2 weeks, we'll do Introduction to Python 2, which will be a lot more normal in the way that it's taught, in that I will actually explicitly go through concepts in Python without using a fairly difficult example to explain them. And hopefully then it will start to tie in a lot of what you've learned today, and you'll see that, oh, actually, no, this is this concept, this is how this works. So I think we've got a few minutes left. Does anyone have any questions or any final comments or thoughts on what we've gone through today? It could be about the Conda, it could be about Jupyter, it could be about RDKit.
Or indeed, if you have any questions about the rest of the series or things that are going to be covered, feel free to put them in the chat or ask us.
Stunned.
You clearly you covered everything so well, Sam, that there's no need for questions.
There's a question from William.
William, so what are some more advanced use cases for RDKit? And Gavin, with help with installing the RDKit, let's talk about that later, because I think me and you are having a chat sometime next week. But tomorrow or later today, I'll send you an email and we'll try and sort that out for you. And everyone else that's having a problem with this, send us an email and we can put on a session just to get the RDKit working for you guys and try and firefight all these problems, because I know it can be very frustrating. But William, back to your question. What are some more advanced use cases for RDKit? All sorts. One of the things that I think is most powerful about it is that you can put in a chemical structure into the computer, and from then, the world is your oyster. There are things called descriptors, which are ways of describing certain aspects of your structure. So one descriptor might be the electron distribution, or it can be as simple as the number of carbon atoms, or it can be as complex as the polarity or the dipole moment. And just by putting a structure into the RDKit, you can start to generate all these descriptors that when you then go and test in real life, if you look at the dipole moment of propane in real life, and you test it using a lab, the RDKit will calculate that for you on your computer. And so if you then want to do some, let's say, machine learning, that's the real buzz thing at the moment, isn't it? If we then want to go and predict properties of different chemicals without having to spend thousands, millions of pounds in the lab, we can put it into the RDKit. We can generate some descriptors based on its structure. These are either numerical or not. We can then do machine learning on them, and all of a sudden, just from the comfort of your own home, you are predicting the way that proteins interact with each other, or you're predicting a new ligand binding site for some pharmacologically active drug. And so don't think of just, RDKit on its own. It's a means to an end, and it's a very useful tool. You then go and if you then use it and combine it with things like, scikit-learn, like I've said, machine learning sides of things, or visualization software, you're then doing some amazing things. My personal experience are in materials informatics, so in the polymer industry. We built some software that relied quite heavily on RDKit, and it could predict whether or not, and to a point, the degree to which some of these pretty cool novel engineering polymers were going to crystallize. And in a commercial setting, the level to which they crystallized was incredibly important when it came to their applicability to different use cases. So fire resistance, hardness, whatever, things like this. And if you wanted to make these polymers, it would take one lab tech or one lab assistant. They could make 2 polymers per week because they were quite intense. We used RDKit, we got some data together. All of a sudden, I can create I could create a data set of like 10,000 different ones, and I can do some predictions on them, and away we go. And it doesn't replace what we're doing in the lab. It aids it, but you can do very, very quickly what it would take years, months, years, weeks, millions of pounds, someone in a lab to do. So I think, bit meandery there, but you can see how just from being able to put this structure in with a bit of Python, you can build it up to real world use cases and save thousands of pounds, millions of pounds, do some really cool predictions. Do I use a Python package to do DFT? I've done a bit of DFT in the past, very, very long time ago. What is the sorry, off the top of my head, I can't remember. The Essex group at Southampton do it, or is it Skylar? It might be the Skylaris group at Southampton do a lot of DFT, and they write some Python wrappers for it. Off the top of my head, I really can't remember. Sorry about that. But they do exist. They are built, they're not built to sort of software developer standards. They're built to scientist standards. So the software is much, much harder to use because we're not quite as good at putting together all singing, all dancing, scalable, easy to use, bulletproof software. But it does exist. I just off the top of my head can't remember. Sorry for that.
Cool. Right, Sam, can I get you to stop sharing your screen?
Oh, yeah. Sorry about that.
No, it's not a problem. So hopefully that's tried to answer all of your questions. Obviously, if you did have any issues with any of the stuff, quite frequently it can be that, yeah, maybe you'll get like a conflict or a package info. And often there are alternative commands that maybe you can try, or it's a slight thing. And it depends a lot on what version of Python you're using, what operating system you're using, what potentially you've done on your computer before. So there are lots of different things.